Hello, and welcome to another episode of Math, Music, and More. Today's mantra, or the whole point of the discussion today, is about be careful what you're thinking and be incredibly careful what other people are thinking and what they're saying and how it should be interpreted too. And no, I'm not talking about behavioral modification, I'm talking about mathematics. And in particular, the subject of real analysis is where I'll give you the example. Real analysis is sort of the first foray that most students of mathematics ever have in theoretical math. And it's the first thing that I ever did, which was super fun, 18100B. And because I'd like to reteach myself things like differential geometry and eventually extend that to general relativity, which I've never studied, I thought, you know what, I'm not in a rush. Why don't I really go through the basics and start to reteach myself real analysis, start to reteach myself topology, go back into differential geometry, et cetera, because I'm just so far away from everything. So I'm just going to take my time and have fun. So my first example in reading the fabled textbook that we used by Rudin, R-U-D-I-N, on real analysis, was the whole notion in the very first chapter about bounded sets, ordered sets, and then the least upper bound property and the greatest upper bound, greatest lower bound property. So first I was reading how he was saying, you know, if you have a set that's ordered and for every subset you actually have that it's actually bounded, then the supremum, in other words, the least upper bound, must be in the set S. And I thought to myself, how could that be possible? I could just create an open interval like 0, 1, right? And as this implies, 0 is not part of the set, 1 is not part of the set, just every single real number in between. Well, I know what the supremum could be for any sort of subset. I could take the whole set as my subset of choice, or I could take the subset 1/2 to 1. It doesn't really matter. There is an upper bound. That upper bound is 1, but 1 is not part of the set. Oh my gosh, what is he talking about? This is an example of sometimes jumping too quickly and not reading things carefully. Go back to the definitions. I was so frustrated just momentarily, I just went back to read again the definition of a bound. By definition, when we say bound, we don't mean that there's a number that's bigger or the least upper bound, just sort of loosely speaking. It has to be a member of the set. By very definition, when we say a set is bounded, it means that that bound is a member of the set. If it's not a member of the set, it's not a bound. Therefore, I made the mistake, not Rudin. But now comes chapter 2. Chapter 2 is when he was talking about the fact that any set that has the least upper bound property automatically must have the greatest lower bound property. And I went through his proof and I thought the proof looked really interesting. But because I'm not in a rush and I love to noodle around in my head, I started thinking, wait a minute, I don't actually think that's true. So I just created an arbitrary set, out of my own mind, where it's kind of, if there is such a word, sort of half open, half closed. I have 0, it's open on the 0 side, right? It's closed on the 1 side. And just for giggles, I did a union with the point +2 and a union with the point -2 over there. So that's the set that I created. Is it an ordered set? Yes. Does it exhibit the least upper bound property? Yes. I can pick any subset I want, however big or however small. The least upper bound will be an element of this set, and hence it therefore demonstrates the least upper bound property. But does it actually demonstrate the greatest lower bound property? Heck no. Because here we have a lower bound, -2, but I could pick, again, the interval 0 1/2. And here, the greatest lower bound is 0, but it's not actually an element of the set. So I can't believe that I spent so much time going crazy about this thing, because there's a very subtle thing here that's happening, in my opinion. And I welcome your criticism or your different perspective if you see something very different happening here. I think Rudin's theorem is correct, and all that is missing is that he's, instead of just saying it's an ordered set, he should have said it's a closed ordered set. But I use that word should very loosely, because I think when he is doing this entire early elementary analysis of real analysis and the establishment of everything that later becomes calculus, etc., he's not thinking of weird sort of, self-proclaimed arbitrary subsets of numbers. He's actually thinking of real ordered, complete subsets, so to speak, of the entire real number line. And because that was his assumption, he didn't say it. But because I'm crazy, I looked at it and thought, no, that's not true. I can come up with subsets that actually disprove his theorem. So I think this is an example of it's great to bring things to the next level of discussion. And it's interesting to note that in this case, Rudin is very clear in his mind what he's trying to say and what he's trying to prove, and he does a great job. But the insertion of the word closed makes it much more tight and correct. So for all of you that are studying real analysis, for all of you that are going through Rudin's textbook, it's a fantastic book. It really makes you think. But there are these little holes in there where you have to fill it in with your own mind, what he means to say, and that unspoken kernel of truth that is sort of a supposition as his mind that is not necessarily openly stated. So anyway, be careful, don't think too fast, and go through the definitions. Don't make the mistake that I made on like page 3 of the text. But at the same time, enjoy some of the holes and these singularities in reasoning throughout the text, because it really forces you to learn the stuff incredibly completely. Hopefully that warning is helpful to all of you. I'll keep you updated if I come up with anything else in the meantime. One of these days I'm going to get back to music, I swear. I keep making promises that I don't hold myself up to. My apologies. Take care everyone, like and subscribe. Until next time, bye-bye.